Now it's time for you to practice the design of our recursive function. For the following problem, I'd like you to work on a function that identifies whether a given string is what we call a palindrome. We can define a palindrome as a string that reads the same from left to right as it does from right to left. Or in other words, the string is symmetrical. Here are some examples of words in the English language that are palindromes: civic, level, kayak, race car, refer. There's plenty of them. We'll also consider the empty string to be a palindrome, as well as a string formed of one single character. While it is possible to come up with an iterative palindrome detection algorithm, that is, one that doesn't rely on recursion, we'll focus here on a recursive version based on the following definition. We can state that a string S is considered a palindrome if it's composed of 0 or 1 characters. For all other lengths, a string is a palindrome if the first and last characters are equal, and the substring discarding the first and last characters is a palindrome. In all other cases, S is not a palindrome. Please pause the video for a second and study this definition carefully. Let's look at an example of how we could use this definition to determine whether a given string is a palindrome. Consider string reviver, which we can see at plain sight is a palindrome. Since it's a string of length greater than 1, we start by comparing the first and last characters. They're equal, which is a good sign, so we continue checking whether the substring composed of all characters except for those two is a palindrome. That would be string EVIVE. Again, we compare the first and last characters. They're equal, so we're still good, and we continue with the internal substring. Now we're left with string VIV. The first and last characters are equal once again, so the last string to check is one formed of character I only. Here we can answer right away that this string is a palindrome, because it has length 1. This answer would propagate up the call tree of our recursive function until we eventually determine that, in fact, the entire string reviver is a palindrome. With this information, you're ready to get your hands dirty. Use the code editor to create a new project named Palindrome, and in it, define a function named isPalindrome. This function takes 3 arguments. The first is a positional argument named text, and the next 2 are optional arguments called left and right. The function is meant to return a Boolean value set to true or false. If arguments left and right are both given, the function must return whether the substring of text formed of all characters between positions left and right is a palindrome, considering that the first character in the string is represented by position 0. For example, let's assume we're invoking isPalindrome with arguments race car, 2, and 4. Here's a representation of the entire string, including the positions of each character. The substring between positions 2 and 4 is formed of characters C, E, C. Since this substring is a palindrome itself, the function would return true. Now, if arguments left and right are not given, the function should return whether the entire string in text is a palindrome. I recommend that you pause the video here for a moment and take your time to understand how exactly the isPalindrome function is expected to behave. Once you complete the implementation of function isPalindrome, work on a main program that asks the user to enter a string and prints whether that string is a palindrome by invoking the function you just wrote. Here are a couple of tips to solve this problem. You may obtain the length of a string with Python's built-in function len, L-E-N, which returns an integer number equal to the number of characters present in the string passed in this argument. Additionally, you may obtain individual characters in a string using the position of that character within square brackets. For example, S square brackets 0 returns the first character of string S, S square brackets 1 returns the second character, and S square brackets len S minus 1 returns the last character in the string. Time to work. I'll be back with my proposed solution. If you enjoyed this content, you may watch the rest of this lesson at computersciencecamp.com, linked in the description below. You'll be able to follow along with coding samples and problems in our embedded code editor. Drop your questions in the comment section below, and don't forget to like and subscribe to help support the channel. Thank you, and happy coding!